Hello all. Welcome to this talk, Glimpses of Axon, which is an event sourcing framework and CQRS included. So we will get into this particular talk. This is before going into that. So let me introduce myself. I am Ismail Shaik, a lead engineer at EPAM Systems India. So I work for Java microservices and distributed systems development, and very interested in trying new things. Then I interested in physics personally, and I love to teach whatever I know. So this is a brief introduction about myself. So I totally have 9 years of experience into software enterprise application development, product development as well. So let's see what is the agenda for today. This 50 minutes talk, what we are going to do, what we are going to cover. And so this is, we are going to just see the overview of Axon. Then we see the Axon framework architectural concepts. Then it's building blocks. Then a live coding session, how actually Axon eases or Axon framework that we can leverage for our application development for specific requirements. So Axon is a framework on Java, which actually used to refactoring your complete application, a monolith application, into event-driven microservices. So this is a very brief definition and introduction from Axon website. So the second part of this particular agenda is, I mean, what exactly? So every technology or a framework would get some will be, the influence or the inspiration would be based on few architectural concepts. Of course, Axon also has some architectural concepts included on which actually it has been built. So the major architectural concepts are CQRS, event sourcing, aggregates. So what is CQRS? It's command query responsibility segregation. We have event sourcing, aggregates. Let us see one after other in very brief. So how actually it helps and what exactly this one. This is the knowing the definition and overview of these concepts are pretty much important for implementing this Axon framework, because these are hard actually. So when it comes to CQRS is nothing but the acronym is command query responsibility segregation. The command query responsibility segregation, it's a design pattern. So what exactly the pattern describes? So it just describes maintain a separate read database and write database. So keep your write database only to write the data and read database from reading the data. Then this is a bit different from what traditionally we see. How come we get the data which has been written to other database and we are reading the data from other database? So two different databases, one is for write, one is for read, and how it could be possible. Yes, we will see how the pattern can be implemented, but prior going into that particular details, so why, I mean, what could be the advantages for this CQRS? So it actually optimizes the performance of the application and scalability as well as security. We will discuss more about this. So a traditional developer or a traditional application, so it looks like the same, like if it is a CRUD operation. Assume that mostly our applications are to create the data and save into the database, read after some time or by a lot of different user set. So we have this presentation is nothing but the UI. Then from here we input the data for storing, validation. After validation, business logic would be process the data. Then using data access layer, we are going to store the data into one particular data store, this one, so which updates the database. Then if we want after some time the same data to be retrieved, then it will go to with the same flow. then the same data store is going to be retrieve the details. Okay, so then what's a big deal here? Of course, this is what which is proven flow, that I can say layered architecture with single database. So if this database is RDBMS, we have a strong ACID, so consistency of the data. But what exactly the problem that I have here actually? But it is not a problem. It is all about the requirements. Here nothing is a problem in software development. It's all about requirements which actually influence the development methodology and the architecture that we build. So this is a command query responsibility segregation. So where we have the same flow from presentation, it go to validation. It's for writing the data. Then from validation, the commands would take the data. Then it does whatever processing it requires in domain logic. Then data persistence, write the data to this write data store, and that's it. Then from here, the data would be pushed to read data store, seamlessly. So without, the presentation layer involved. So the write data store, whenever the data updated, it would get synced with the read data store for reading operation of this particular data. Then again, why I want two different databases for the same data? I have a simple use case here, where if you take online journal, so the editor group or who are going to post the articles or the news on the journal would be limited. I can say, for example, 10 people. But at the same time, who are reading the particular journal could be millions. So at that particular time, for writing, it is more recommended to use ACID properties. So RDBMS is my best choice for consistent data to be written, for a transactional based data to be written. But whereas if I want to read the data from that particular RDBMS itself, which is scattered across 100 tables or many more tables using normalization techniques. So then to get required data, the queries could be in different forms. So we can't restrict, the database can't restrict how query has to be found, but that is all about requirement. So joining 100 tables, then getting the data would definitely impact on performance latency of the read. So query. So as a simple thing I can see, I will write into the write data store for consistency using my RDBMS database. From here, whenever data has been written to this database, I will process that particular data into a NoSQL document, and I will store into the read database. So seamlessly, this is going to be synced from RDBMS to NoSQL. So whenever I want to read the data from a query or a UI or anything, then it is only a one click and one document that I am going to retrieve, which has 100 tables data when it compares to the write database. So this is one of the use cases. And before going into CQRS, exactly where actually I have a very good experience with the CQRS, because I was working for a very big retail chain few years ago, where the data has been scattered across almost 200 or 300 tables, so different data. So for writing, that's a RDBMS, which is a licensed one, and the scalability becomes very huge. And at the same time, now I need a mobile version or a mobile UI, mobile interface to access that particular data for business leaders. So then to get that particular data, I have been ended up with joining at least 50 to 60 tables, which actually a latency. The latency would be high. So the mobile users, of course, right, in a second, if it is not going to be response, then we used to uninstall that app. That's how actually the user experience has to be considered. So with that performance criticality, that forced me to have to go with this CQRS, where I will maintain another database for the mobile users, where the mobile users, based on their particular data, in a single click, I can get the whole information just like that in a second. So what exactly I did? So the store in charge or different employees used to write the data into the RDBMS. Then using change data capture, I used to capture all the data 50 or 60 table at a time whenever it has been changed immediately. Then I used to process into one single document and I push it into the read data store, which actually helps me. This read data store has been connected to the mobile application. So whenever we require, it's kind of a search engine that I used here as a read data store. According to the filters the business users given, the performance was very high. So which actually solves my problem. So this is one of the use cases, but we have to sacrifice here consistency, immediate consistency. Rather, we can leverage if we can able to tolerate the eventual consistency, the CQRS is the best solution for gaining the performance. I mean, apart from performance, what exactly we get more? So independent scaling, of course, when write users are very minimum and read users are high, then at that time you don't require to scale your write database, just increase the read database or create multiple instances of the read database. Rather, write database cannot be affected with it. And optimized data schemas, actually that is what we have been discussed. For write, I choose RDBMS for strong consistency, whereas for read I go for NoSQL because it is only read only. So I can leverage both data schemas for my different requirements into one application. Security, yes, of course, writing the data, updating the data is a very critical part than reading. I mean, in most of the cases, at the time we can leverage, like we would give a high security to the write database, whereas I mean accordingly the read database too. So but the security levels would definitely differ from write to read. So separation of concerns, yes, this database is only for writing and this database is only for reading. And the simpler queries, as I mentioned, that query, a single document is going to be queried by the read operations into the read database. So in the light of microservices, how it can be utilized? So my choice is here finding the order history or order details. Then I have multiple services: order service, kitchen service, delivery service, and accounting service as well. But whenever the order has been done or kitchen service has updates, everything is going to be push the data to order history service as events. So I store those events in a incremental manner into the order history database, so that whenever the user is going to be query for a order history or a order, I don't again require to go to order service, kitchen service, or delivery service. Rather, I can go to order history database itself for retrieving the order details. So these are all going to be in sync all together every minute, so that we can achieve the performance scalability as well. Right, this is a brief overview of CQRS. Then we have the another thing is event sourcing. So event sourcing is nothing but which is used to persist the state of the business entity, or I can say it as a table row, as a sequence of state changing events. So if I say order, so we have that particular diagram. So this is what. So order 101 is going to be created first. Then 101 has been approved. Then 101 got shipped. So it is in an incremental way, which is 901, 901, 902, 903 for the same order. So I can replay all this again to get again going to a particular state. So if I can say here, I can say at this particular stage my order entity has been approved. So I can define my state here as an event. Right. So again, event sourcing requires storing of event. Then what exactly this event store? So usually we store these events into a database. We call it as a event store. whereas event store can be a message broker which will actually push or pull the messages based on the configurations. So it provides API as well. So this diagram depicts actually how a event store is going to be integrated with the application. So it can write a new event, it can write the new events to the event store, and even it can retrieve the past events to replay again, or whatever, I mean, according to the requirement, it can utilize those particular events. Right, so we have, so far we've seen these architectural concepts. So let's go and see the building blocks. So what do you mean by this? Architectural concepts are just concepts based on which have been influenced to design this particular framework. Then what are the pillars for Axon framework that actually implemented this CQRS, event sourcing and aggregates? So the building blocks for Axon framework are commands, events and queries, and we will see one after other anyway. So usually, if on a broader picture, if you can say an application, generally a CREDA operation application, most information systems use only two approaches. One, write the data, another one is read the data. Then you write the data and you are giving command, write this particular data to the database. Then you query the data based on the filter condition, then the data would be queried. Then in between, to coordinate these two, or to get into the sync between the commands and queries, the events are the mediums here. We will go. So this actually command handler is actually responsible for handling the commands of a particular type. So we would have different commands for different types or different processing tasks. So it's again, you know, completely segregated according to the task. So again, we have an event handling, so event listener, which are going to be listen to the events, incoming events, and they get pushed to the events that those are going to listen components. So we have two different set of components. We have an event. So if one is a producer and whoever actually subscribed to that particular event, then it would get actually that particular event. It is just like, you know, YouTube subscription. So I have my own YouTube channel. So whenever you have been subscribed my particular channel, then whenever I uploaded a new, you know, video in my YouTube channel, then you will get a notification about a video has been uploaded. Then according to your wish, then you are going to be take action whether you would like to see or not. That's all again, you know, that's a other side wish. So the query handler, so we see so far, like we are writing the data, then now I want to read the data. So this is another kind of an operation, most common operation. So that's why Axon segregates the separation of concerns, like I write the data using commands, read the data using query handling. So these are the components which actually query the messages and get the data from the database and present it to the user who actually queried for it. Okay. In a single picture, if I can say how actually Axon is going to work, this is what my perspection. So we have here, you can say command handler is going to write the new events to the event store. Then this particular event store is going to be, you know, getting into the projection logic. Then this projection logic updates the read database, and that is what simply if a query handler requires any data, then it is not going to be processed from event store, rather it going to retrieve the data from projection database. Using the selection criteria, the data will be retrieved, whereas command handler can also retrieve past events in a sequence manner to replay the events or whatever processing it requires. So see, it is just that it is a bit deviation from a traditional where controller to service to DAO, rather we won't decide the component which are going to handle, but we can actually configure it. So event store. So what could be the event store in Axon? So even Axon has its own event store using Axon server. It provides the infrastructure as well to have the event store, its own event store. But even that actually provides the extension to the RDBMS technology, NoSQL technology, even to RabbitMQ and Kafka. So you can store your events not only into the Axon database, Axon DB, which is in a Axon server, but you can actually store it into any relational database that it provides the extension, or any NoSQL one. So let's come to this particular diagram after our coding session, so that we would actually can conclude with a particular overview. So I was telling about the Axon server before jumping into the coding. We require to know how actually it is going to be organized. So Axon server is a middleman here, so which actually maintains the Axon database. Whereas these are three different services in the microservices system, application, architecture, or whatever what. So these services are going to register with this Axon server, whereas any service can listen to the events, or any service can write the events to the Axon database. So Axon server is a middleman here. So please remember the terminology: commands, queries, events, and Axon server. So in our coding, other than these four, not much thing involved. So let's jump into coding. So to demonstrate the programming model of Axon, to demonstrate this particular coding of Axon, I have created a Spring Boot application. So this is something called RD session. I have given a name for the project. So, but majorly this is what we see: source. So in source, the package structure I actually, not me actually, Axon recommends are command, query, and core API. So you remember from our discussion. So command is going to be have all the data, all the classes which actually handling the commands, and queries are used to contains those particular logic to retrieve the data, and core API actually has the definition of what command segregation. So we will get into the details in a minute. So we are going to see on this particular application how actually command handling can be created here, query handling can be created, and how event actually getting sourced or event stored, then how actually the event handler, the actual traditional way of application development has been changed to command query communication using events. So this particular just give me a minute, let me increase my font size, settings. Let's have make it as a 20. Okay. So I hope everyone can able to view the screen and you can able to read the code as well. It's out of window, so that's fine. I give it as 16. Pretty much fine. So this is just a Spring Boot application. where actually I have user details, registration, and updating the user details, and reading the users, and deleting the users. So it's only CRUD operation, but I have actually a simple use case here, like a user would be registered with his unique identity and name and salary. So then this application would be processed that particular data, and it given back actually in the query that how much loan he can avail at max. So the processing would be based on the salary. Then we will see how exactly it will be going on. So this is my REST controller here. This is user controller. All I have is CRUD operation, which is create user, update user, delete user, then get the users based on one particular user ID, or get all users. So a simple thing, not much complicated. But now, for example, if I am going to create the user, so I get the data enquired user. So what exactly enquired user has? So I have a unique identity of my, the PAN ID is nothing but it is permanent account number in India. We use it is for identification of a person for tax submission. So so generally what exactly we used to do in a traditional way, that from controller directly we are going to associate the processing logic to one particular service or any service. But rather this particular Axon, how it actually manages, rather it is going to call a service, it actually call a command. So what exactly the create user is going to do? It's a create user command. Then it provides a command to take this particular creation of a user task. Then who is going to take that command? We don't know at this point of time. So this controller never knows who are going to take this particular one. So this command again is kind of a key. So whoever actually handles that key is going to be processed that particular command. So let's go to command, what exactly the command is all about. So commands would be annotated with command handler, and command handlers would be written in aggregates. Again, what is aggregate? So on a very lighter note, I can give a brief, but because aggregate is a concept of domain driven design, but I don't want to get into much into this one. But I can say aggregate is nothing but which actually aggregates all the entity operations into one single thing. For example, if I say here the user aggregate, I can I have aggregated all user operation. For example, from a database perspective, I have user items, user addresses, user actions, different entities, but rather I work on entities separately. I combine all together operations into an aggregate. I provided it in this particular user. So my point of control on any user, entity operations would be from this particular aggregate. So hope clear. So every aggregate would have aggregate identifier. I will let you know what exactly the significance of this particular aggregate identifier. Yes, the aggregate should be have a no parameterized constructor. Then this is required by Axon. So then we have command handler on a constructor as well as on a method. So why constructor, why method? Again, on a demo, then I can explain. But till that time, assume that both are methods itself. So then what exactly happened here? The controller just sent the command as create user command without specifying who is going to be handled. So this Axon framework would identify this particular command, create user command, where exactly it has been handled. So I can say that create user command has been handled in this particular method. For now, I mean, assume that it is a method. I mean, why it is a constructor, we will see in a demo. Then create user command is going to call. So the control will come here and it would compute. In the command, I send all the details of the user. So I mentioned about the salary there as well. So if you see here, my command has my all details, name and salary. So these commands carry the data to the processing unit. So from here, I compute the loan eligibility. So into the 10 multiplied by 10 to the salary. And then I have been done with the processing of that particular command. Now, where exactly this has to be go save the database. So here command won't take responsibility to store it into the underlying database. Rather, after processing, it is just trigger an event. I mean, I don't know who are going to take care, but I am triggering this particular event called user created event, where command dot I will pass whatever data required for that particular event. So along with the permanent account number, ID, name and salary, I actually send the max loan amount which actually processed in this particular command. So now, then who is going to take care of it? Then again, Axon framework. So that is again event handler. So it would be defined using event handler. Whoever are going to be, handle this particular kind of a event user created event, that particular method is going to be invoked. So here I can say it is a user created event. So it is taking this particular event using event handler. Then I have my own logic to persist into the database. So this is how actually the command handler would process. So if we see the different commands here, for creating user I have one type of command, and for updating user I have another kind of command. For deleting user I have another kind of command. Command gateway is a component which is used to send the commands to the appropriate classes or components. Then we have another thing called query gateway. So query gateway, as we see now commands, we can have query gateway. So it will actually query using this particular query object, but this particular controller don't know from where actually this query is going to be executed. Again, using whoever are going to be listening to this particular find user query, that is going to be take care of returning the data. So where exactly it is, again we are going to user data projection, which is a simple class component, Spring component. So whatever query is going to be handled, that needs to be annotated with @query handler. So here I have been triggered from here find user query with a particular user ID. So I am going to search who is going to be handle this particular query. Okay, come on. So this particular method is going to be handle this particular query. Then it is going to be written whatever logic has been placed there. So from here the control comes to with the information that we have been requested. So this is how generally, so all your commands, events, everything would be there in here, with the details to be carried from one component to other component for the processing. So this is pretty much straight. These are nothing but just POJOs, whatever core API consists of. Yes, let's go and run this. I mean, I want to eagerly look the output of this particular data and how Axon works. So before starting that particular application, let me show you. So this is Axon. So Axon server can be downloaded from the Axon website, or it has a Docker image as well. So just get that particular image, Axon server image. You can search in Google for Axon server Docker image. Then you can get that image and you run it into the Docker as a container. Then you can start. The default port is 8024 for Axon. Then you would be landed up with the standard version of Axon server, which is open source. So this is the Axon dashboard. Till now I didn't do anything on my Axon service, so no commands. So these are the commands, those are registered, and no commands, no queries, nothing. So, and overview, you can see here. So one instance of application is running here. So if you have multiple applications here for the same Axon server, then You have even you can run on a cluster as well here. Okay, seems my application has been started. So right, so what exactly my query of this particular application 8080 slash, okay, let me know what exactly is, this is the user, right, slash user. Okay, so now I have no users. So I hope you can able to view my screen. So there are, it's an empty array. So I don't see here. I don't have a fancy UI anyway because you're all techies. I used to present the data in JSON format for creation as well as view purpose as well. So let me create the data and let's see here how it works. So my post HTTP method is going to be create a user here. I have been given my permanent account number which is unique as ABCD123Q. Of course, it is not my permanent account number. Please don't try to access it. So I have my name as Ismail here and my salary as 200 USDs or whatever not. I mean exactly it is into INR but it is not 2000 for sure. Um, let's send let's trigger this particular one. So okay, come on, I got a 200 status, so I hope a user of Ismail has been created. Let me check. Yes, of course. I got created here. So whatever I have been provided, it's my PAN ID and name and salary as an input, but my command actually calculated the max loan amount that I am eligible based on my salary, and it has been stored into the database. Using query handler, I can able to retrieve the data here. So now let's create another one, like R, and the name is Brad. The salary, he has much more better salary. It's 2500. So then let's post it. Okay, now the second user, I assume it has been created, but let's see exactly he has been created. Yes, of course, yes. So another user, the name with Brad has been created with 2500 salary. So based on that, the loan has been max loan amount is going to be calculated 10 times of that particular salary, and we can see here two users fully. But even I have a query here. Sorry. But before that, what exactly happened in event sourcing? I say I have been command as a data, then it has been persisted. But in between, I have an event sourcing as well. So what? Right. Come on. So two events have been created with different aggregate identifiers. So aggregate identifier is unique for every entity of that particular aggregate. So in this particular case, ABCD123Q is an unique aggregate identifier for me, whereas the other thing would be for Brad. So it has been created for the first time. So the aggregate sequence number, this is nothing but the sequence number. It has all payload that we have been passing with all data here. So we can see exactly what exactly this event has been triggered with. So if you see here, so it has been created with the number, PAN ID, name, Brad, salary 2500, max loan amount 25,000. Then what is the type of event has been created. So we can have all the details. This is the event source for me. Now, how actually event sourcing happen? How exactly it is going to be happened? Let me try once again. So my PAN ID is Q. Okay. So previously my name actually I have been given only Ismail. I forget to give my last name. I just want to update my name as well here and my salary details as well. And now I get an increment 300 USDs, then 3000 USDs. But I mean, this is not my actual salary. Please don't get into the illusion. This is just for a demo purpose. So now let me update my user details. Okay, now this is a previous data that I have. So now what exactly happened with me? Oh, come on. My name has been changed from Ismail to Ismail Shaik. My last name has been updated and my salary as well from 2000 to 3000. At the same time, my max loan amount has been, changed from 20,000 to 30,000. So yes, I mean, why we require this update? Because we want to see here. You can see here, right? So this is another event has been appended, which is this has the same aggregate identifier ABCD123Q, ABCD123Q, but with the different sequence numbers. The first event was a creation event. Now the second event was a update user event. At the same time, we can see this how many times which command actually executed. My create user has been executed twice because I have been created Ismail and Brad. At the same time, I updated only Ismail details. So one update. So how many queried? So I have been queried 4 times. Now let's query a specific person, that is Ismail. Now let's see how many queries happen. Now find user query, a specific user query 1 time. So this is how we can monitor the data here. What exactly we require? Yes, let me update the Brad as well, right? So Brad also get some updates. Then I mention Brad. I have been append his name with the last name as Brad D, and he has been updated with the salary 4,000 USDs. Now I just did send. Okay, 200. Now let's see. Now oh, come on, he also get updated. Now my projection database has all data which is recent one. But what happened with my old data as well? I mean, the old data is going to be stored in your event store. Yes. So where exactly? Here. Oh, okay, cool. So I have 4 events here. So now I have 2 events for ABC, me, and 2 events for Brad. So this is how the events are going to be append on every operation on a particular aggregate. Now I just want to reiterate why actually I have been mentioned here. It is why it is on a method, why it is on a constructor. See, whenever aggregated actually first instantiated, in this particular case, when user created, that is the first operation. The first operation, using first operation, I created this aggregate object. So that's why the command handler would be on the constructor. Okay, whenever it has been done, your aggregate identifier has to be assigned with actual ID of that particular data. So when event has been triggered, then the event handler and event sourcing handler are going to be updated. This is at least for the first time. So we can maintain the track of sequence of the events for that particular aggregate. This is going to be very useful, pretty much useful here. So if I say here, how can I let me check what exactly happened here. I have too much of data here, so then let me check only Brad details here. So now Brad. Okay, come on. So this is what Brad has been created. Brad profile has been created and Brad profile has been updated. So with the sequence of 0 and 1. So even I can delete Brad as well. you can, we can delete. So I thought it, I'm going to delete. So yes, 200. Yes, I think he has been deleted, but let me check whether it's actually deleted or not. Come on, yes, it's only me here. So Brad details are not there. Brad, what happened with the event sourcing? Now, oh, come on. An event has been added here with a sequence of 2. So this is a completely timestamp sequence, whereas the lower one is a very, earlier event that has been happened. From if I come from lower to upper, the very recent is a delete operation, or the first operation would be the user created, then updated, then deleted. Even if I did the updation multiple times, all are going to be, persisted in this particular event store. So this is how actually Axon works. Is the simple demo that I had shown. So this is a complete picture of our Axon. We have from UI I given a command handling component, take it and it persists into the storage, which is nothing but the event store. Then it publishes events. So event handling component is going to be take it up and it is going to be provided into the storage, which is nothing but a projection storage. So then the UI can query directly to the query handlers to get the data from this particular store. This is a brief picture of how actually Axon frameworks organized. So this is the Axon server. As I mentioned, every event is going to be stored into the Axon database. Then events can be read by the services, or events can be appended by the services. Okay, cool. So these are the references. So for the documentation, you can reach out to these particular URLs. I mean, there are Axon framework, a GitHub project as well, which actually demonstrate a trader operation or a trader application. So you can leverage this one to understand more better. Okay, finally, so you can reach me here. So you can Gmail me at ismail.epam@gmail.com. Then I'm on Twitter, so you can reach me at you can tweet me at Ismail, ISMAREHAN. Of course, Rehan is my wife name, so don't confuse. This is my LinkedIn profile, and the last one is nothing but my community Z profile. So you can see my profile there, or you can message me anytime. So I would give as best as possible the reply. So I will keep some time this particular slide. Okay. Let me read through few questions. If I have. Yes, Wagner mentioned that both databases are completely equals, or is some changes before data goes to read-only data store. Yes, it's again your requirement. Yes, if you ask me, yes, for writing I choose RDBMS in my particular case, and I actually process whatever data I have been written in the right database, change into the NoSQL document altogether, and it put it into a single document inside the read database. Whereas the query guy querying can be much more easier. That is what actually the intention of the CQRS. That on read-only store. Yes, again, Wagner again mentioned like heavily transactional. Yes, I mean, see, heavily transactional also fine because you're writing, but what exactly the requirement is, if you can able to sustain eventual consistency between writing and reading, then we can go for CQRS. But if it is a real-time data, but you no tolerance for the delay, then it would be tough to choose this CQRS. So what to put in command, what to in event. Command actually carries the data from your UI or whatever you have been triggered. So command takes the data for processing. The command is going to process your data, and then again it would trigger an event with the processed data. The event handler is going to be store or whatever it wants to do. So command usually have the user data given by the user, whereas event would have processed data from command generally. Yes, we have Saga pattern. Vadzim mentioned. Yes, Saga pattern is there with the Axon framework, of course. But with the time restrictions, I can't able to continue on a Saga pattern. But yes, I mean it's a good documentation to we have on Axon website. So you can leverage it. Actually, it has a Saga store as well. They can use to store the Saga details, whatever happened. But it has a very good support for Saga. I mean, whenever again I got the chance to participate or speak on this kind of a platforms, definitely I would take Saga patterns for next sessions anyway. Thanks. Or you can write me, or I can give my GitHub link. I mean, I forget to mention here, but you can write to me, then we can discuss even offline as well. Yes, we have a Saga pattern. Yes, that was actually intended. I thought it into the India. Yes, Vatsim, tomorrow we have a Saga pattern session that I'm going to organize. I'm going to take it. Yes, you can join that particular session. Then it would be definitely a fun, in discussing about it. But you love it definitely. So I see no more. Okay, Maxim, yes, thank you very much for the presentation. Thank you very much for your, patience and, valuable time to listen to me. Again, I mean, if you see any, different opinions on this particular talk or, concepts that we have been discussed, please write to me on this here at my Gmail or at Twitter, LinkedIn, messaging or community Z. So I'm always be available. I will give as soon as possible the response. Very nice talking and sharing knowledge with you. So let's see you on another session. Goodbye. Have a very nice day, and we have more valuable sessions here. Thank you guys. Thank you very much.